So, hello everyone, and hello everyone online. My name is Orestis Konstantinitis, and I come from the development side of Cinema 4D. Um, so, I'm a user experience designer based in Germany at Maxon, and during the last few years, I had the privilege of being on a team of very talented people that were working on the Fields project. So, I'm here to talk to you about it. What the fields are, essentially, is a complete replacement of the Falloff system of Cinema 4D. So the Falloffs are like procedural 3D masks, and they are in many different places in cinema, in MoGraph effectors, in Deformers, dynamic forces. So in all of these places, now we will have the new fields. Before I get into too many specifics about what the fields actually are, I would like to show some of the examples that were done during the development cycle. So in this example by Glenn Fry, we can see a cloner animation that is being driven by an animated vertex map that even belongs to a different object. In this burning cloth animation by beta tester and friend of mine, Gunter Nicodim, again, it's an animated vertex map that is driving the parameters of the cloth simulation. And here, again by Gunter, he made this 3D growth animation. And this example is made by another beta tester, very talented Christian Wolf, that he made this beautiful reaction diffusion animation using the new fields. So what are the fields? To answer that, we should take a look at how effectors used to work until now. So a typical effector would consist of these parts. It would have a driver component, which could be a sound or a shader or a formula or indices or something like that, and it would be driving your effect. It would have a parameter part, and this is where the users would go to define what kind of parameter change they would like to happen. So if they want to change the position, the scale of the rotation, or the colors, or the time offset of the animation. And this is basically your effect. And it would have a Falloff part, which are basically 3D masks for your effect. So we can visualize the effector as this compound object consisting of these three components. And out of these three components, the only one that has an actual 3D shape is the Falloff component. So the first thing that we did is we split out this component, and we made the Falloffs now their own individual 3D objects in the scene. And this has a number of benefits. First of all, by having the Falloff as a non-object, it means we can apply it into multiple different objects at the same time. So we can use one Falloff as a 3D mask for multiple effectors, deformers, dynamic forces, all at the same time. And it also means that we can use our normal 3D manipulation tools to comfortably manipulate this object. So we can move it, scale it, rotate it, constrain it to somewhere else without needing to take along the object that they are affecting, such as the deformers, which they care about their own 3D coordinates. All right, so far so good, but why do they call them fields? That's because the fields are more than just the Falloffs. So if we take a look at the drivers, we said that they are driving your effect. What does it mean? It means like if you have a sound as a driver, if the sound is loud, your effect is going to be stronger. And if the sound is silent, your effect is going to be weaker. So it's driving the strength of your effect, but this is what the Falloffs are also doing. So the Falloffs are like 3D masks, and if you are inside the shape, your effect is strong. If you're going towards the edge, the effect is going to be weak. They're doing similar job. And in fact, we could probably use the drivers in the same place we used the Falloffs before. And that's what we did. We took all of these drivers and we brought them into the field system. So we're trying to unify tools that are doing similar job. And we have more tools that are doing similar job. We have more tools that affect the strength of your effects, such as the weight maps. You can paint by yourself where you want the effect to be stronger. And the selection tags, you can make selections where you want your effect to take place. So if we take a look at where we started with the Falloff system, this nice system that existed everywhere, we just had the Falloffs. And now we have all these different types of data that exist. And they're brought into the same unified system. And this is what the fields essentially are. They're a data unification system, and in a way, they're a data transfer system. So we have all these different data that are coming into cinema: shaders, sounds, volumes, weight maps, vertex colors, geometry information, splines, and more. And we can blend them together. We can combine them. Each one of these data types is basically a different field, and we can combine the different fields together. So the way we combine them is we have this new interface list, and we just drag and drop our fields as layers, and it's basically like Photoshop or After Effects. You can choose how to blend them with each other. So you will find the same blending modes that you're probably used to from this software, such as add, subtract, multiply, screen, overlay, etc. And we try to keep the workflow very interactive and efficient, so you can change the blending mode right there in the list, or you can adjust the opacity of every layer right there on the list. To create new fields, well, you can create them from a menu, but for the workflow's sake, we also have these embedded buttons at the bottom, and these are essentially palettes. So each one of them opens a palette of fields, and you can choose which field to create. We categorize them into 3 categories. So the first one are the Falloff objects. These are real 3D objects that will show up in your object manager. So you will find all your old Falloffs in there, as well as some new ones. The second category are the field layers. These are fields that don't need to exist as 3D objects, so they don't need to clutter your object manager. So these are fields like the time field, or the step field, or the weight map field. And the third one are the field modifiers. So the fields come with a powerful modifier system, and these fields are a bit special. You can add them in your list, and they will change the values of existing fields in your list. They're like adjustment layers in a way. So they can remap the values of existing fields. And there are some special modifiers as well that I will talk about a bit later. So basically, the fields have a value that you can drive your effects. But not only that, the fields have a bit more than that. They have 2 additional data channels that you can use. So the fields have colors. So each field can have its own colors. And they have directions, which are essentially like vectors. And each field can have its own vectors. So these additional channels will show up only in the lists of objects that they can be supported. They won't be always visible. They will only be visible when they can be useful. So deformers, for example, they cannot colorize objects. You will not see these data channels there. But effectors, they can apply colors as well. So the color channel will be available, and you can enable it or disable it on a per layer basis. The directions are a bit special. So only the Target Effector can support directions, because it can orient the clones based on a vector. But you can also find the directions in Xpresso or in Python if you want to use them in a more technical way. So we mentioned that everywhere where we had Falloffs, now we will have the fields. But also, there are some new places now. So we can also apply fields to selection tags right now. So polygon, edge, point selections, as well as MoGraph selection tags can use the fields to be written procedurally. And also weight maps. So vertex maps, MoGraph weight maps, as well as vertex colors can use the fields to be written procedurally as well. And a new very exciting place where we can use the fields is the new volumes. So not only we can use volumes as fields themselves, but we can also convert fields into volumes. So we can create something like this. This is basically a 3D noise that is placed inside a shader field and then voxelized and then meshed. So we can easily create meshes like that. This mesh is created by Matthias Zabigli from the studio Xponza. And this is another example by Tim Clapham. So he took this head model, and by using a single field, which is a noise again, he can sculpt all these intricate details into the model. By the way, Tim was here as well this week, and he's amazing. Not only he's an amazing artist, he's an amazing tutor. So if you haven't checked his presentations, you should definitely check them out. I also made a few tests before we go into the demo to demonstrate a few different example cases where we can use the fields. So in this case, I'm using another new feature of Cinema 4D, the multi-instances, to create this grass field using MoGraph clones. And this is another very exciting thing we can have in R20 right now. We can use MoGraph for landscaping like that. And I'm using the field directions to emulate the wind effect on the grass. Here I'm using, again, the fields with the volumes to create this growth effect of the head mesh. And here I'm doing a growth effect again, but this time inside a deformer, so I can morph this cube into a spheres and vice versa. And here's another example with the multi-instances where I'm using an animated character, and I tried to use the fields to randomize it, make a crowd, and also randomize the animation if possible. So I randomize the scale of the models, and using the fields, I was able also to affect the speed of the animation. So when the model is smaller, it will walk faster because it will have a smaller stride. All right, so I think we can stop with this and go directly into Cinema and see how they actually look like. So I will start with a very simple setup. Here, matrix object, add an effector, and the first thing I want to do is just to reproduce my old workflow. I just want to add a Falloff here. So if I go to the Falloff tab, which is highlighted, we can see that everything changed here. All the interface is gone, and now we have an empty list. So all I want to do here is add a spherical Falloff. So I will go to my first palette over here where we can find our Falloff objects. I will add the spherical field, and basically I'm done. I just reproduce the workflows we used to have, and a bit extra because they also get the field colors. But I don't have to stop here right now. I can keep adding things, so I can add another field. So I add a spherical field on top of this, and now I have two fields on the same object, and they both have their own colors. If I want to change the color, I can go to the Color Remap tab here, and I can choose whatever color I want. Or you can turn off the colors completely by turning off the color channel. Now they're using a max blending mode, so their positive values are combined, but I can change that. I can use something like multiply, and then the linear field is multiplied on the spherical field. And basically the effect I'm having is that I can wipe the spherical field using this linear field. So let's move to some other examples. So we said that everywhere where we have the Falloffs, we can use the fields. This time I'm using it in a deformer. So I'm having a displacer deformer. I use my spherical field. Everything works as expected. But the case here is that I have two deformers. So I have a second deformer, and I'm still using the same field on the second deformer here. So it's a second displacer with a second pattern. Now I can enable both of them, but then they get overlaid, and the result is not very nice. But I can go just to the second deformer here, and if I go to its own field list, I can add a modifier layer just for this deformer. So I can add an invert modifier. And then the effect is inverted only for one of the deformers. So I have one deformer inside the sphere, the other deformer is outside the sphere, and I control them using the same field. But I don't have to stop here. So we can apply the fields in many different places at the same time. So here I created a vertex map, and I'm still applying the same field inside the vertex map. And the vertex map, we can use them in turn in many places where we didn't have fields, such as materials. So in this case, I have a material, and I'm using the vertex map shader as a mask for two different patterns. So if I apply the material onto my object, I'm basically controlling the deformations as well as the shading of this object, all with one single field. Now in this case, I take it a little bit further. So instead of using the spherical field directly onto the deformers, I'm using a group field. So the group field is basically like a field list by itself, and I can add other fields, combine them, and use the whole group as one single field. So in all of these places, I'm actually using the group field, not the spherical field directly. And if I go to my group field, I can add more fields in here, and then they should have an immediate effect into all of these objects at the same time. So I think this example demonstrates nicely the new workflow that you can expect using the fields. But let's take a look at some other examples. So another new place where we can use the fields are the vertex colors. So in this case, I'm using a standard particle emitter to write these vertex colors procedurally. So let's take a look at the stack here. It's basically three layers that are doing the job. So at first I have a solid layer which has this color, a little brighter than just black. Then I'm just using the emitter. So based on the proximity of the particles, is giving me these spots here. When the particles go closer, I'm using a spiral, a rotation force to make a more interesting effect. And then I'm just multiplying a random field on top of it to get some colors out of it. I can show a new modifier in this case. So a new interesting modifier is the decay modifier. This is like a wet map. This layer can remember the values a bit more, so it can decay them a bit slower. So I'm just enabling the color of the decay. I'm going to crank up the strength a little bit more. So now you can see that the colors can have trails a little bit. And if I make it all the way to 100%, then they will never be erased. They're just painted. So it's like a wet map, basically. And here's an example we also have on the website. This is made by Jonas Pilz, which is the quick tips guy, one of the Maxon video quick tips guys. And he used the decay field to make the wet sand effect in a very easy way. So next, let's take a look at how we can use the fields with the volumes. So we have a new volume menu here where we can make a volume builder object. This is how we can create volumes in Cinema. So I'll just create a volume builder, and then we can put fields inside the builder directly. So if I go to my create menu, I can create a random field in here. I put it as a child of the volume builder, and immediately we start to get something. Now the builder is set to sign distance field. It's basically one of the two modes that we can make volumes. The sign distance field is meant for surfaces, and the fields don't really have a surface, so it's not ideal. You can still use it, but it's not ideal. The fog mode, on the other hand, is a kind of more infinite way of creating volumes, and it's very compatible with fields. I don't have to see the preview of the random field anymore because I can see the voxels directly. If I lower the resolution, now it's just random. Let's give it a noise shape here, and we start to see something. And if I drop it under a volume measure object, I'm going to get a model out of it. So just like this, I create the model of a 3D noise. And I still can go and change the settings, of course. So let's make it a little bit bigger. All right, so let's explain a bit how this works. The fields are basically infinite, so it needs to know where should it create it. If I go to my builder and I select the field, I get some special options for this type of object. So I can choose the creation space. In this case, it's a bounding box. So if you want to make it thinner or shorter, you can adjust it right from here. But this is only the beginning, because from here you can start playing around, combining different objects. So let's go to the side view and add a spline into the mix. So this is the beauty with the volumes system, that you can add any types of objects. So let's just draw a quick spline here and see what we get from it. So we're adding it into the builder as well. And then I'm getting the mesh of the spline. It seems to have steps, so I can go to the spline layer this time. It will have its own set of options. I can crank up the density, and I want to subtract it. I'm going to subtract it, and then everything disappears. And that happens because the measure is using an adaptive threshold right now. And by subtracting the spline, I went into negative values. And basically, the 50% threshold now it has a value of 0. I just need to adjust the value a bit higher, and then I can get the mesh that I want. And it basically created, it drilled the noise using the spline. I have a camera here where I can constrain it into the spline so we can see it a bit better. So I can create this elaborate tunnel just by combining a noise with a spline. And we can crank up the resolution a bit more. Let's try to work on it a little bit to see how we can deal with troubleshooting. Now I can see these little steps now that I increase the resolution a bit. And this happens because if I look at the spline, it has a voxel Falloff of just one voxel, and this is not enough. So let's increase it a little bit more, and then I can get a smooth transition in here. So everything is still procedural. I can go and I can change the noise type into something completely different, and I get a very different result. Or you can go, of course, and you can adjust your spline whenever you want. It's going to be a little bit slower because I'm using a high resolution grid. But basically, that is the idea. Let's take a look at another example of fields with volumes. So in this case, I'm using a normal polygon object. Let's do something more traditional. So I'm going to make it into a fog volume as well, and then I'm going to mesh it. So I just created a volume version of my text object here. And I want to combine this with fields. So this time I'm going to create a group field. So the group field allows me to combine many different fields and create some more interesting stuff. You can see that it also creates it inside a bounding box. Now the group field is completely empty. But this time I can change the creation space. I don't want to use a bounding box because actually we already have voxels here created by my polygon mesh, and I can use them in the fields, which is a great and very efficient way of combining fields with objects. So just change these two objects, and that means it will use the pre-existent voxels that the text already created. Now, let's change this to multiply as well, and go to our group field and put something in it because it just has values of 0 right now. So I'm adding a linear field, and this linear field is going to be multiplied on the voxels of the text. So I can wipe the text using the linear field. But basically, this is like a Boolean effect. I can do it with objects, nothing too interesting yet. But I can start combining fields right now. So I can add a random field into the mix, and let's hide it. And let's set it into a nice noise, and let's change the blending mode. So the overlay mode works really well for this because it will only affect it during the transition of the linear field. So I just created a much more interesting transition than a simple Boolean operation. And I can crank up the scale a bit more. So this really elaborate transition effect can be done really easily using these tools. So these are a couple of ways you can expect to use fields inside the volumes. Let's take a look at the directions. So I created this grid with arrows just to show where they're pointing. And we said that the directions are available inside the target effector. So let's make a target effector. So nothing changed so far. I can go to my Falloff tab. I can create a Falloff here, which is basically just a Falloff for the previous effect. So these are the directions without the field. These are the directions with the field. Let's delete that. But if I go to the effector tab, I can change the target mode now to field direction. And this will allow the target effector to use the real directions of the fields. So what can we use here? I have a model. And I want to use the model as a field and use the directions of the fields. So the way we can use a model to create a field out of it, we just have to drag and drop it into the list. And it's kind enough to allow us to make a point field for free. So we can disable the Falloff. So I can have an infinite Falloff and just see the directions of the field. And now we can see that the arrows are pointing towards the points of this object. Now if I move the object a little bit, we will notice that some clones are popping. And that's because they're aiming literally at the closest point on the mesh, and the mesh doesn't have a lot of points. But we can easily fix that if we go and set it, instead of points, use surface. This mode is slower, but it's far more accurate. So now they're aiming at the closest point on the surface of the model. Another very, very cool field to use for directions that I think will be very useful for our users is the spline field. So you can draw splines and draw the directions using the splines, basically. So let's draw a spline again here. And I'm going to use this spline inside the target effector. Again, I'm going to turn off the Falloff, so I'll have infinite Falloff. And you can see that the clones are now oriented along the spline. So let's see it on the perspective view here. And so the clones are orienting along the spline. Now, it's worth noting that every one of these fields is a whole new feature, basically. So if I select the spline and I take a look at the options, I have a bunch of options here that I can play around with. So now it is set to along the spline. That's why they're going along the spline. I can change this to something like radius, and then the clones are aiming towards the spline or away from the spline. Now they're aiming away. I just add an invert modifier, and now they're aiming towards the spline. Let's raise the spline a little bit to see it clearer. So this is a very easy way to start controlling your field directions. And since we can use splines, I made another example in here where I'm using hair, because hair can generate splines itself. And I'm just generating a few hair here. I have my target effector. You just drag and drop your hair just like before. And now if I brush the hair, I'm actually brushing the directions of my MoGraph clones. And this just works because of the nature of the system. So it's another interesting use case. Let's move on, though. Let's see some other examples. So these are some new places where the fields exist, point selection tags. So I'm using the fields inside the point selection tag. I have a spherical field. Whatever is inside the spherical field, it will select. And then I'm using the point selection tag inside the bevel deformer. So if I move around the spherical field, it's going to change the selection, which is going to change the bevel deformer. So essentially, I'm changing the topology of the model by using a field. Let's take a look at the polygon selection as well. So here I made the selection manually, and I'll just drag and drop a material on my selection. It made the selection tag, and it constrained the material so we can see it pretty easily. So we have this checkbox, use fields, we enable it, and we get a field list. And this field list is not empty, it's already populated by this freeze layer, which is very interesting because it saved my own selection in this layer. So now I can add more procedural layers, I can add more fields in here, and I can combine them with my own selection. So if I add a linear field here, we can see that it's combined with my own selection. I can change the blending mode to something like multiply, and then the linear field is multiplied on my own selection, so I can reveal the selection that I made manually. And basically, you can use all the power of the fields inside these selection tags, which is really interesting. Another very interesting field to use with selection tags is the formula field. Because the formula field, I'm going to set it to normal mode, so it can override all the other layers. So this is the default formula. You can see it's changing the selection based on the formula. But the formula field also allows you to type specifically the index you want. So you can type whichever polygon index you want to select. You can unfold here. You can see in the variables that the variable for index is ID. So if I say, for example, ID equals 50, it will just select polygon index number 50. Or I can say ID is smaller than 50. It will select all the polygon indices that are smaller than 50. Or if you know a little bit more about formulas, you can start playing around. So you can use something like a modulo operation, which is really interesting for creating patterns and cycles. So I can say modulo ID 2 equals 0, and then it will select every second index. Or I can say ID 3 here, and it will select every third index. So you can use basically all the normal power of the fields inside these selection tags. So let's take a look at some more examples. So next is Xpresso. Because Xpresso had a Falloff node, and now the Falloff node will have the fields. Now, a lot of people are afraid of Xpresso, but I think it has a very straightforward use case that is very useful and very easy to use. And that is controlling any parameter of the object that you want using the field system. So people are intimidated by Xpresso, but let's see it together. We start by making an Xpresso tag here, and we just need to drag and drop the object we want to affect. Next, I'm going to right-click, and I'm going to follow the yellow highlight to find the Falloff node. All right, and then I want to connect it with the parameter I want to affect. So let's go to our object, find the parameter we want to affect, in this case, the growth. So let's drag and drop this parameter on the node, make the connection, and then you're done, right? So you have your Falloffs here, so you can create a Falloff. Let's close the Xpresso. And now I'm affecting this parameter using the fields. So let's try to do something nice. I'm going to use a time field. So the time field is a field that its strength is going to be increased with the progress of the timeline. So now this is being animated automatically. It's animated all the way to 100%, but you can clamp it if you want to and set it, put the limit 85% if you want. So now it's only going to grow until 85%. And now I can show another modifier. Let's make the delay modifier. So this is a very cool modifier that can have a spring effect for your values inside the list. So let's set it to spring. And now I'm having the spring effect just for this parameter of this object by using the Xpresso in the fields. But let's try to see another use case, because I want to show another feature as well. So here I have this T-Rex. It's from the content browser. So another very cool feature that we're added in R20 is the ability to easily bake to Alembic, very easily and efficiently. You just need to right-click on the object, you say bake as Alembic, and it didn't even pop out a dialog for me to choose a file. It just baked it, it brought it into the scene, and kept the material of the object. So this previous object had a bunch of joints, expressions. It was driven by a C motion. Let's just delete everything. And I just have a single Alembic object now that I can scrub on the timeline and works fine and works fast. So it basically just saves an Alembic file into your project folder. Another very cool new addition of Alembic is the ability to remap your animation with Alembic. So now you have this remapping curve that you can use to remap your animation, or you can turn off the animation and you can animate it by yourself using this frame parameter. And since I have a parameter that when I'm adjusting it's moving the animation, I can use the field just like before. So let's try to do it really quickly. Let's add an Xpresso tag. Drag and drop the object. Find the parameter you want to affect. Drag and drop the parameter. Right-click, follow the highlight, make the connection, and you're done. So if I make a time field now on the fields, this is going to play in real time. So this is based on the time field. Like if I reduce the strength, it's just going to play slower. If it has 100% strength, it's going to play in real time. And you can start playing around now, again, with the power of the fields. So you can add something like a quantize modifier, which is another very cool modifier, which will quantize the values inside the list. So you can have this stop motion effect really cheaply. You can adjust how many steps you want this to quantize, actually. And you can add more modifiers. Let's add the delay modifier again. So the delay not only has spring, it has other modes as well. So in this case, I have a smooth mode. And I'm having this kind of dubstep effect, I think, by using the quantize modifier and then the delay modifier. Or you can go back to the very popular spring. And then I can have a spring effect on the animation itself while it's being quantized. So this is a couple of examples how you could use Xpresso with the power of the fields. All right, next I want to show one of the examples that I showed with the keynote presentation before. So the transition, the growth transition between a sphere and a cube. Now this is very interesting because, as you probably noticed from the examples, the growth seems to be the major attraction point for everyone. So let's see that as well, I think. I'm going to first demonstrate how the growth works, very simply. So in this case, I have a plane. I'm going to crank up the subdivisions, and I'm going to make a very simple weight map. All right, go to our weight map. Just like the polygon selection tag, I'm going to enable the fields, makes me a field list, gives me a freeze layer, which has my map saved in there. Now, the freeze layer is a very interesting layer. Not only it saves our values in here, but it can do some proximity operations. So if I select it, I can see a bunch of attributes here. And if I change it to something like an average, let's just see this a bit clearly. This is basically blurring the map that I painted by myself. And I can change the radius anytime I want. So the blurring is procedural, actually. It still saves my original map here. And there are more modes that you can use. You can use something like a max mode, so you can expand your map a little bit. Or you can use a min mode and contract your map. Or you can use a grow mode. So the grow mode is a bit special. It's kind of like the expand, but it's kind of a preset mode, so people can use it really easily. You can build it manually, but this mode is a preset. And what it does is for every frame, it's going to save the new state of your map into the layer. So it expands it a little bit. It will expand it now 12 centimeters, and then it will save it, and then it will expand it again. So it's going to save it on the layer, and then expand it another 12 centimeters. Save it on the layer, expand it another 12 centimeters. And so this is like a simulation. If I add an obstacle on it, it will go around it because it grows on a per frame basis. And now if I hit play, basically, so all you needed to do is switch to grow mode, hit play, and you have a simulation of your map growing. You can adjust the effect strength here if you want it to grow a little bit slower. But all right, so the next problem is that this is a very boring shape, and this is where the simulation power will come in. So you can add more fields on your list and affect the way that the map will grow. So if I add a random field here, let's add a nice noise shape, like this, and set it to overlay, which is a great mode because it's a combination of multiply and screen. So now you can see that the shape changed completely, just as simply as that. So that's how I made the effect earlier. I just used a growth like this. So let's try to do it. So I have my cube here, and I want to make it a sphere. First of all, I want to make it a sphere using a deformer. Obviously, it doesn't have enough subdivisions for being a nice sphere. Let's crank this up. And I'm going to make it a sphere using our old Spherify deformer. Let's bring the strength to 100%, bring the radius down a little bit, so it will keep approximately the same volume. And let's make a vertex map again so we can see the growth. You can actually put the freeze layer in any list you want. It doesn't have to be a vertex map, but the vertex map is really easy to see. So let's make the cube editable, bring our paintbrush here, and dab a little weight as a starting seed. Select our vertex map, enable the fields, select the freeze layer, set it to grow, hit play. And now it starts growing. All right, so how do I use this inside the deformer? Well, in order to use a vertex map inside your field list, you just drag and drop the vertex map. It's going to make you a vertex map field. So just like this, I created a much more fancy-looking effect with my Spherify deformer. All right, so far so good. It has a bit of rough edges here, and that's because if I go to my Spherify layer here, I can select my vertex map, and we can see that the mode is set to nearest point. I can change that to something like average. So it has similar functionality like the layers before, so now it has a much more smoother transition. So around 10, I suppose it's OK. So now it gives me a nice round edge. All right, but I want to make my growth a little bit more interesting. So let's turn this off, go back to my vertex map. And I want to add some more layers to mess around with on the growth. So before I use the random field, this time I'm going to use a shader field. And the shader field allows you to use textures, shaders, and basically use them as fields. So let's try to add a shader here. I'm going to add the tile shader, which has a bunch of interesting patterns inside. Let's adjust the colors to have a bit more contrast. So first of all, you can see that the tile shader now is being converted into a vertex map via the field system. And I want to have the spiral pattern. That looks really interesting as a growth. So let's see how that works. Let's set it to overlay again. Hit play. And we see the pattern actually changed quite a bit of the growth. But let's see if we can take it a little bit further. Let's select our freeze layer, adjust a little bit the values, bring the effect strength down, make it a little bit slower, which will also bring up the shape of the shader field a bit more. And now I have much more elaborate effect. So I just need to enable my Spherify deformer, and everything is here via the vertex map. Everything is working. All right, so far so good. But I think we can take it a bit further. So in order to make it a bit more organic, I'm going to add another spring effect here. So add a delay modifier, set it to spring, and let's see how that works. Hit play. All right, it's a bit more organic, but it looks a bit weird. And that's because right now the list only produces values between 0 and 100%. And to have a nice spring effect, you need to overshoot a little bit more than 100%. So in order to unclamp my list, I have this little icon on the bottom right, which looks like a clamp. So you just click it and you unclamp it. And now you can see the unclamped values. And you can see some really beautiful waves forming up. All right. And this becomes a rather elaborate effect, just like this. I'm going to drop it under a subdivision object and see how it looks. So this can give us smooth results while preserving a lot of the details of the transition. And I think it's quite interesting how we can get these elaborate effects from our Spherify deformer. This deformer is so old, maybe it's older than some of our users these days. So it really brings new life into these tools. Let's turn this off. And, well, the only thing I want to add on this, and let's see how we are on time. We're good on time. That's nice. Is a linear field to go back into the cube shape. So from cube, I go into a sphere, and then I'm going to return. So how are we going to do that? Really easily. I just want to reset the values back to 0, right? So let's take this linear field over here, set it to multiply. Let's hit play, see what's happening. And let's add a few more frames, actually. All right, so maybe around here, I'm going to animate my linear field. So let's add a keyframe here and go a few frames forward, bring it on the other side. So it's multiplied on the values. It's going to reset them back to 0. You already saw the deformer jump back to 0, and it had also the delay effect. Add another keyframe. All right, let's see what we did now. I'm going to enable the subdivision surface. It becomes a bit slower, but it looks nicer. So the slowness actually doesn't come from the fields. It actually comes from the subdivisions in this case, but you just have to enable it during rendering, actually. I just want to see a quick preview here. So in this case, you create this elaborate effect via the growth, and then just wipe it back using the linear field, and basically you have your effect. All right, so I'm very glad that we have time to show another example. So I want to also show this head growth example that I showed earlier. So let's see how that will work. So in this case, I have my head model, and again, I'm going to start by making a growth, so which I'm going to use this time inside the volumes. So let's take a look. Paint tool, maybe add a little dab of weight here. Enable the fields, set it to grow, hit play, and it's growing. Oh, that's perfect. All right, so let's make it a bit slower. Let's add another noise onto the mix. So let's set it to noise. Let's see how that looks. All right, maybe the noise is a bit small. Let's bring it up. All right, so you can adjust the values to get everything in there if you want to. So I can reduce the effect of the noise a bit more. And maybe increase the effect strength here. All right, we're getting there. So this actually happens because I was a bit too lazy to add points at the bottom. So let's just stay with that. I think it's good enough to show the effect. All right, so let's turn this into a volume. Let's drop it under a volume builder. And we already have a volume. Let's bring down the subdivision. So this time I'm going to use sign distance field. This object has surfaces, and it can make it into a nicer mesh when I finally mesh it back. So let's mesh it, see how it looks. So this is the mesh version. If I decrease the voxel size, I'm going to have a more beautiful result. I can drop this also into a subdivision surface to have it smooth. But I'm going to focus on the animation right now. So let's bring up the voxel size a little bit. All right, so I want to combine this now with this vertex map growth. How am I going to use a vertex map as a volume? Well, you can use it via a group field. So let's make a group field in here. And we said that this is a field list, so I can drag my vertex map into this list. And let's see what happens. Now we have our group field combined with our head mesh. And I'm going to set this also to use the object voxels, just like we did before. So now we can see the vertex map growing as a field this time, using the voxels of the object mesh. The sign distance field has some voxels outside and inside the mesh. So in this case, I just added the group field by mistake inside the vertex map as well. So I just deleted everything. Let's try this again. All right. So basically what's happening is I have my vertex map growth just like before. It's a combination of a freeze layer, a random field. Then I'm putting the vertex map inside the group field, which I'm putting inside the volume builder along with my head mesh. All right, so I have this. This is not very useful, but if I change the blending mode here of the group field, instead of union, let's set it to intersect. So it's going to intersect only on the common voxels of both objects. So basically we're done. Yeah, we have our effect here. Let's give it a nicer material. And now the only problem left is that the edges are a bit rough. Let's decrease the resolution a bit. And indeed, we can see it has a bit of rough edges. So we can go to our group field and set the mode again. Instead of nearest, set it to average. So now it's a bit much. Let's set it to 10 centimeters. Try this again. I also increase the resolution. So this is the kind of effect you can expect. You can still try to tweak it, but I think it is enough as demonstration purposes. All right, so that concludes my presentation. I hope you like it. I hope you really enjoy the new system and you find some cool uses for it. Thank you very much.
Bye.